to watch. It'll take about 10 minutes, and it's on chemical equations. And I really don't want to... What we talked about on Friday with the reaction, here's a different one. This is photosynthesis. We have, it's a process that changes. So we're going from reactants or starting materials to products. And then what I have for you on the board is the photosynthesis reaction. We have our carbon dioxide. Carbon dioxide's in the air. It's absorbed by plants. Plus water. We give water to our plants and it's absorbed. It yields, which means it's going to make, utilizing the sun, so we use those here, it's going to make oxygen, which plants give off oxygen, and they make glucose, which is over here on my right. These two these two starting materials here are called reactants. It's very similar, so reactants is right here. It's very similar to how you bake a cake, how you bake cookies. All your ingredients are your reactants, and it's going to yield, meaning we put in the oven for heat, it's going to yield a cake or cupcakes or cookies. So these two ending materials over here are going to be products. Now, these chemical reactions always involve changes in chemical bonds. It's a rearrangement of those atoms and bonds. So nothing is created nor destroyed, it's just more of a rearrangement. Now, this energy, it is released when chemical bonds are broken. So when these two, let's say for water, when these bonds break, so we have H here, when these bonds break, it's going to release energy. And then what we're going to happen is in plants, photosynthesis, light energy is going to be transformed to chemical energy, and that energy is going to be used to make the glucose, which is one of the ending products of photosynthesis. But what you do want to take from this is that when bonds are broken, it is going to be releasing energy, and when they are made, it's going to be absorbing energy. Here's the next slide that you guys should have, that these chemical reactions that release energy, they often occur spontaneously, which means they don't need something to start it. However, reactions that absorb energy will not occur without a source of energy. And this, folks, is the potential energy we were talking about before. And many times, those reactions will need that jump start, or will need some of that energy to be lessened so that those reactions can occur. And one of those items that we talked about on Friday were enzymes. Enzymes will decrease that potential energy that is used to start those reactions. We, as organisms, we need to carry out these reactions that require energy to stay alive. We release energy when we grow, we breathe, when we even think. Your metabolism, you guys utilizing energy, you're making energy, that's how you can function in my class, is usually, hopefully, you've had some sort of breakfast. But even when you dream, there's chemical reactions happening. So remember, you have your starting materials, which are you call your reactants, and then you have your ending materials, which are called your products. What I was talking about on Friday a little bit, or today, was this type of energy that is used to get these products or to get these reactions started. So over here, we can see this course of reaction. Here we have our reactions here, and we have to kind of climb up the hill to get our products. This right here is the activation energy. It's that energy needed in order to get those things started. As you can see here, here's a course of reaction. We have our absorbing one. This one was cut off. We need to go uphill, and as you can see here, we're going to get our products. This one is an energy releasing reaction to where you're going to see more of a downhill slide, to where it's not much of an uphill slope, but as we get to our activation energy, this is what is being released. Here, this is what is needed, or that potential energy being absorbed. Now, getting back to enzymes, as you can see here, see if I can't change the picture, but the catalyst that I was talking about is any substance that is going to speed up that reaction. So you can see here is our reaction, the normal reaction here. Okay? Excuse me, the blue is the reaction right here. As you can see, it's required much more energy here, or the active energy here. When you have the enzyme, you're either going to produce more energy or you're going to release more energy. Okay, so this enzyme here, reaction pathway with the enzyme, is not utilizing as much energy. And again, an enzyme is a catalyst. These are proteins that we're going to be talking about later, that they act as catalysts, and they're going to speed up a reaction. So that is the lecture. If you guys want to stop and rewind, I'm just going to take questions on Tuesday before lab, and then we'll get started. Have a great week.